Okay, so we know that the derivative of log x is just 1 over x. So this is just one of our formulas that we've discovered for differentiation. Now we also know this, that if we have something like this, let's suppose we have not just log x, but let's suppose we have log x squared, something like that. Well, we know the chain rule is involved in this one. So we've got to take the derivative of the outside, use our formula for the derivative of the log, but then we multiply by the derivative of the inside, which is x squared. And of course, this would just reduce to 2 over x. And there we're done with it. It's this chain rule part that sometimes gives us difficulty. And for that reason, a lot of times it's beneficial to recall some of the rules for logs, some of the properties of logs. In other words, if we have log of uv, remember that's log u plus log v. And also if we have log u over v, remember that's log u minus log v. And also, if we have log u to the r, that's going to equal r log u. In other words, we want to utilize these properties here. Now, let me show you how that would work. Let's look at this problem, this derivative that we just found. We want the derivative of x squared. Now, let's write that this way. Let's write that as the derivative of 2 log x. See, what I did was I brought the 2 over. I brought the 2 out front. Okay, now we're assuming that x is greater than 0 here. Okay, so if we do that, notice I have 2 times 1 over x, and I get 2 over x. There. And you notice that that's exactly the same as this. So what we're doing is we're utilizing these properties of logs to get at the derivative. So let's suppose we have this. Let's suppose that we have the log of 2x plus 1 over 3x plus 5, something like that. Well, let's do this first. Let's use our properties of logs. Let's call this the log of 2x plus 1 minus the log of 3x plus 5. Now, let's go ahead and use the properties of logs. This is going to be, or let's go ahead and differentiate now. This is 1 over 2x plus 1 times the derivative of 2x plus 1, which is just 2, minus 1 over 3x plus 5 times the derivative of 3x plus 5, which is just 3. And look what we have here. We have 2 over 2x plus 1 minus 3 over 3x plus 5. And if we wanted to, we could, and let's go ahead and do it. Let's go ahead and I'm going to combine these. So I got a common denominator of 2x plus 1 times 3x plus 5. So I've got 2 times the denominator over here. In other words, what I'm doing is I'm building up this fraction here by multiplying the top and the bottom by 3x plus 5. And then over here, I need to multiply the top and the bottom by 2x plus 1. So by the time we do that, the bottom is just 2x plus 1 times 3x plus 5. See? Because over here I multiplied by 3x plus 5 top and bottom, and over here 2x plus 1 top and bottom, and that gave us the same denominator, and then we just combined the numerators. So let's see what we've got here. We've got 6x minus 6x, 10 minus 3, that's 7 over 2x plus 1, 3x plus 5. And there we have it. There's our derivative right there. Okay, now let's look at one that's looks a little complicated if we don't use the properties of logs. Let's suppose we've got x to the fourth times 2x plus 1 to the fifth times 3x plus 5, something like that. And we want to find the derivative of that. Well, here's what we can do. We can utilize these properties of logs because that's going to make it a lot simpler. So here we go. We've got, and let me just put this little bracket here. We've got x to the fourth plus log 2x plus 1 to the fifth plus log 3x plus 5. There we go. Now we're not finished because, well, what I can do now before I start differentiating, I can write it this way. I can say, okay, this is going to be 4 log x. This is going to be 5 log 2x plus 1. And of course, this is just, nothing's changed here. But notice, bringing these exponents out front has made things a lot simpler. So now let me differentiate term by term. I get this one first. This is 4 times 1 over x. Done. That one's done. Plus 5 over 2x plus 1. Don't forget the chain rule, times 2. See, derivative of the inside. Plus 1 over 3x plus 5. Now, if we wanted to, from this point right here, we could go ahead and combine everything, you know, get a common denominator and build it up